golly. That was my own wonderful speaker coming out of myself. But yeah, I'm on summer holidays. I've got some really cool things planned. I actually went from Wales last week, which was really cool. I wonder what everyone's been doing so far. It'd be great to share on the chat what you've been up to. But at the moment I can see that Xenon994 is here. I can see Mears91. Hello. Let's have a look at other people if anyone's on. Got some lovely ideas here. I'm buffering a lot. Okay, I wonder what's going on there. Let's have a look. Is it clearing up? Where are we up to? Can we say hello? Are we all here? Oh, I see. Hello, hello. Where are we up to? That's fine. Oh. Some people have got it okay. Fine by them. Oh, lovely. That's fine. All right. Well, let's crack on, shall we? I've got some really cool things to show you all today, which I'm quite looking forward to. But so far, today is going to be me talking about how does damaging the brain teach us so much about it, which is going to be really exciting. Tomorrow, you've got philosophy with Nish, which is to be confirmed what it's going to be on. I mean, that is maybe the own philosophy itself. English with Mr. Phil Wilcox, looking at co-writing a book. On Thursday, we've got science, can seaweeds save the planet? That's flipping cool. With an inspiring guest, Dr. Adriana Verges, or Verges, I don't know how to pronounce it. And then finally with Dr. Hannah B, we've got science. Why do we get shorter as we get older? Hello, Leonardo Pes. I hope you're doing well. To start off with, what do you have to break to use? And I can think of 4 things so far, but I'd love to see what you all in the chat had to say about this. What do you need to break to use? Any ideas? A glow stick, Mears91. Such a great idea. Glow stick. That was one of the 4 that I thought of. Lovely. Anyone else got any ideas of what things? An egg, Mears91. You are absolutely smashing it. An egg, well done. Anything else that people can think of? What do you need to break to use? A can! Oh, I like that. I didn't think of a can. Like a can, you've got to open it up and then kind of use it. You have to break code to use it? You have to break code to use code? I'm not sure always. I'll write it down anyway, but I'm not sure you always need to break it in order to use it. Break ideas, to use ideas, sort of like break down ideas. So if someone gives an idea, let's break it down, let's get it critical. I like that. I didn't have that as well. I like that a lot. Ideas. Any other ideas that we've got? What do you have to break to use? To use an egg to break it, use a glow stick to... Any other ideas? What do you have to break to use? I'm thinking of maybe like a secret message. Oh, to crack the code. That's really cool. Oh, do you think that's what was made before? Oh, with Leonardo Pez, I see, like to crack a code, to break a code. I see. I was thinking more like code, like 1s and 0s on a computer, but that makes sense. All right, that's really cool. I have another idea that is maybe something to do with some safety. If things are going quite wrong, you might have to break. A cold pack. Love that. Yep. A cold pack. You need to sort of break open the chemicals inside to react and make it nice and cold. Break chicken to eat. Oh, I see, like breaking, if you're eating different meats, you might break some of the cartilage or the bones within it in order to eat them. So, okay, so generally like food, you break it down in our body to use that, those chemicals in us. That's really cool. I love that idea. One thing that I was thinking of is something like one of those, you know, the glass that behind it might be some sort of item to use. So, you know, like you might need to break some glass and behind it is like an axe to use as a fire axe to get your way out of something. So you might break glass like to escape, to use, or something like that. Yes, breaking emergency windows, things like that. That's a really cool idea. One thing I thought of something to break, and this is just something simple, it's just general packaging, right? Just general packaging. You might need to break the packaging of a piece of food, like a crisp packet. You break it open, and then you eat inside. You're a little bit late on OMNH, but not by much. You're going to be absolutely fine. We've only just started off. Ideas that we need to break in order to use, because the whole idea of this is that we know so much about our brains when they break down. A huge amount of the knowledge of our brain is when it breaks, funnily enough. Now, this website here, I actually wanted to put into the chat, but there's been a little bit of an issue. I can't quite type into the chat at the moment. But this website is a really cool website I wanted to share with everyone of exploring the brain. If you go to Google, I'll show you how I found this website, so maybe you might do it yourself. I'll keep my annotations. If you go to the Google and you type in interactive brain, and look for the one that says Koshland Science, and then it gets to this here. This is the one that I thought was quite cool. Hopefully you can see what I can see. No, your brain isn't actually a rainbow colour. These colours were just put in to show the different parts of the brain. So the part of the brain in yellow here is your frontal lobe, because this is the front of your brain. So your eyes would be around here. Your brain, this is the front part of your brain. This we call the parietal lobe. We have the occipital lobe at the back here in purple. In green is the temporal lobe, and down here we have something called the cerebellum, which is really cool. And you can kind of move it around. You're welcome to look yourselves, but also you get to see the interior view. This is the inside of the brain, which I just think is absolutely beautiful. So many different parts. Some key parts that I really like is this part here, which can be highlighted, which is called the amygdala. The amygdala, these little bits here. The amygdala is one of my favourite parts. This is on the inside. So if you look at the exterior again, this is the outside of your brain. I wonder if you guys are doing this yourselves. This is the outside of your brain, but if you sort of take away all these outer bits and we look on the inside, it looks like this. It does kind of look like an alien. I love this. What to search? OMH, NPH. If you go to Google and you search interactive brain, and then look for the Koshland Science one, it should come up with this here, which is really cool. And yeah, it looks like an alien. Yes, exactly. Thank you, Miz, for helping that out. But this is the inside, and yeah, the amygdala is really cool because that's part of your fight or flight response. Leonardo Pez was asking about the pituitary gland, which is here, this central part, the pituitary gland, which is an amazing part of the brain, this tiny little part of the brain, which is in charge of a number of different things. As it says here, is a primary hormone secreting structure. It works with the hypothalamus for controlling hunger, thirst, sleep. Now, all of this, if I looked at, for example, the hypothalamus, right, hypothalamus, it does kind of look like a ship from Star Trek. Yeah, it's so true. Hypothalamus here, in charge of sleep, body temperature. All of these parts we know about. But how? How do we know that if I click on the temporal lobe, is important for processing sound as well as the ability to recognize and understand words and language? How do we know this? How do we know that this part of the brain, which for me is my sides parts of the brain here, how do we know that that's in charge of all of that? If I click on the occipital lobe, we know that this the hindbrain, the back of the brain, is responsible for visual perception, being able to see things, and visual. Now, Xenon 994, you've spoken about the idea that it's there for autopsies, and we learn about it from autopsies. Now, a huge amount of our research is autopsies, but just getting a brain out of a human and looking at it, it's going to be quite difficult to learn, okay, well, this part does this for their body. We need someone alive in order to work out what parts of the brain link to what actions in the body. Using brain scans, says Leonardo Pes, absolutely. When we do tests, can't we see which bits are being used? Yes, we can sort of do tests, but it's all a bit complicated because in reality, those tests are quite complicated. Now, of course, it is quite illegal to, these days, get someone's brain out and just poke around in it unless they give permission. And it is actually possible to test someone's brain whilst they are awake by basically working out and poking around the brain and seeing what happens. We're going to look at that now. Now, this man, Phineas Gage, was the first ever recorded instance of a brain damage turning into knowledge in neuroscience. Now, Phineas Gage was absolutely incredible. And I'm going to tell you a little story, about Phineas Gage. Now, Phineas Gage was a miner, right? He would mine things, right? And during his job, a major part of his job was to dig holes and then put some dynamite in those holes and then blow up the dynamite, and then that hole would be bigger and then you could mine more, right? That's a normal part of a job. Now, this guy, Phineas Gage, what he did is he went along, he put the dynamite in that hole, and then, unfortunately, the dynamite blew up too early, and he got this actual metal piece, this sort of, it's a metal rod, basically, and that went through his head! It went through his brain, in through the bottom, out through the top, and made a hole, as you can see, that it kind of went through him that way in his head. Now, as 1 Million Sloths has said, how is he not dead? You're right. How didn't he die? We learn from film, from TV, that if you get kind of a brain damage or shot in the head, it's like gone, you're out. But that's not strictly true. Phineas Gage is the first recorded example of someone who had this iron rod go through his brain and he came out the other side, totally alive. But the beauty of this experiment is his personality changed. He was not the same person after this as he was before. Now, over to you. I'd like you to look at the parts of the brain that were damaged. The parts of the brain that were damaged were mainly his frontal cortex, okay? Mainly his frontal cortex. So let's go back here, right, to our brain anatomy. I'm going to touch frontal lobe. You're welcome to do this as well. This part of the brain, frontal lobe. I want you to tell me a little bit about how you think he changed as a person after this accident happened. So the frontal lobe serves a number of important roles in behavior, including planning and initiating movements, social and emotional processing and attention. The frontal lobe also involved in working memory as the ability to retrieve and store memories. So Xenon994 thinks maybe his memories were stored there. Actually, a lot of your memory isn't necessarily stored in the frontal lobe. Apart from something called the working memory. The working memory is the type of memory that's very quick. It's the kind of memory that you need just for everyday tasks. There's long-term memory, which you recall things from years ago kind of thing. Then there's short-term memory, things that you might recall on the day. But frontal lobe isn't really in charge of those times of memories. So he became really boring, 1 Million Sloths says. What do you mean by he became really boring? It'd be really interesting to hear what you mean by that. OMHNPH says his left side would be messed up. You're right. So the part of the brain was the left side that got damaged, and there would be some issues there, but how would that have actually changed his life? So he had amnesia, not quite Leonardo Pez, because amnesia, as we said before, is to do with either short or long-term memory, not quite short-term, not quite working memory. Did he have problems coordinating himself? Love the idea. Yes, he had some issues in his behavior, in parts of his movement he had issues with. He had no interest in what he used to be like. That's really interesting. Yes, his interests, his likes and dislikes changed after this accident. He would be blinded in one eye. That's true. The damage to the eye happened, but that wasn't to do with his brain as such, more to do with the connection between the eye and the occipital lobe, which is where we have sight. He did survive Leonardo Pez. Yes, he definitely survived. If the right side of the was broken, it would be wonky on the opposite time, the other way around. Interesting idea. Be wonky on the opposite time. What do you mean by that, OMHNPH? But I can tell you all now that his personality changed in a number of ways. He actually became more aggressive. Right? really interesting. He actually became a little bit more aggressive. He became a little bit more impulsive, right? So he didn't really think as much about what he was going to do until he did it. So he just kind of went out of his way to do things just because he thought he could. He became more aggressive, a bit more impulsive, a little bit different, so less interested in his loved ones. Right? Some people that he used to love and care for, he didn't really care about them as much anymore. He became difficult. Yes, indeed. All of this, and the fact that all of these personality differences changed, gave neuroscientists an incredible new learning into that part of the brain. Scientists and neuroscientists could conclude that those parts of the brain must therefore have a major part in personality. And this is the major idea of how damaging the brain can influence learning about it too. Now, I want to look at some brain studying techniques, because now we know that if we can see a problem part of the brain, if there's a part of the brain that we can spot which there's an issue in, then we can start to work out, okay, there's an issue in this person's back in the brain and they're finding it difficult to see. That must mean that the back of the brain might have something to do with vision. Let's have a look here. What I'd like you to do is give yourself a go. This is going to be quite difficult to work out. Can you say out loud this word, this top word? I wonder if you can say this out loud. Obviously, I'm not going to be able to hear you, but I'd love to hear if you're able to say this word, then this word, and then this word. There's quite long neuroscientific terminology, but I want to see absolute classic school time activity. See if you can link which of these three words links to these three images. Okay, so Mears91 can say them slowly. I will say them for you now. This is the electroencephalogram. Electroencephalogram. Electro, meaning it's to do with electricity. Encephalo, which is part of the brain, right? And gram, so it's going to produce some form of data one way or another. Then we have the transcranial. Trans means like through. Cranial means the skull, so through the skull. Magnetic, so it's to do with magnetism. Stimulation, so it's something to do with stimulating things. We've got some ideas. Xenon994, TMS links to the top right because of the magnetic fields. Amazing work by OMHNPH. That you can see that there is the magnetic fields, and this is that, the TMS. Well done. 1 million sauce thinks the one in the top right is the first one. Good try, EEG, but it's not correct. The EEG is one of the other ones. And the final one is the functional, goodness, my whole life. Right, the functional magnetic resonance imaging, or FMRI. Who thinks the top one, EEG, is this image or this image? Which ones do we think? Which one is the EEG? Which one is the FMRI? Which image goes to which, do you think? The bottom right is more of a scan. Well done. The EEG says Vendible Sugar, and Anna Evans-Wolf is this one here, which means this one's down there. As you can see, this is a human being going into this massive, right, this massive magnet, basically. You're not allowed to wear any metal during this. I actually had an fMRI when I was doing psychology at uni, not because I had a medical condition, but because there was a study, and it was really cool. You kind of get slowly moved in, and then your head's in this giant kind of magnetic space, and you get these incredible results, which I actually have on a CD, and I'm going to show you my results. So the electroencephalogram is this. It's got, you kind of put on like a cap, and on that cap there are many little electrodes, and they work out different brain activity in the brain from an electrical standpoint. The transcranial magnetic stimulation, that's an incredible, wonderful piece of kit which we're going to look at, which basically stimulates parts of the brain. This is a really cool one. It's more recently. And finally, a functional magnetic resonance imaging is something that uses the iron in your blood as a magnetic precursor and works out where does your blood go in your brain when certain things are going are happening. Now here are 3 GIFs, and I would like you, again, similar idea, which of these is a result from the electroencephalogram, which of these is the result from the transcranial magnetic stimulation, and which of these is the result of the functional magnetic resonance imaging. Just to give you an idea of what's going on in this bottom right hand corner, this is a man who's having this, one of these 3 techniques on him, and at the start he's actually trying to say "bar bar black sheep," but this thing is being turned on and he can't really speak properly instead. It's amazing how it impacts it. So is EEG top right? Well done. This is the electroencephalogram showing different parts of the brain and the different waves that's going on when certain things are happening. I've had EEG go on my head, and it's really cool because you can see these results as it's happening, and if you start to think of different things or start to blink or move around your body, then you can manipulate the different results that's going on. That's really cool. TMS is bottom left. I think you might mean bottom right, but you're absolutely right. TMS is at the bottom here, which means that FMRI gives this. Now, fun fact, that is my brain. Those are the results. I made a GIF of my actual brain. You're looking at my brain there. Isn't it massive? And so detailed and so intact. Isn't it cool? Now, this is my brain from 3 different angles, right? This is the brain from right to left, right? So here is right to left, so sort of going this way, right? From right to left. Here we have from back to front, so it's going this way and back. And this one at the top is going from top to bottom, right? Top to bottom, so it's going up and down like that, which is really cool. How long did the MRI take for my brain? It took, I think it must have taken about half an hour. Honestly, I've forgotten because during the experiment I actually fell asleep. It was really relaxing and I'd had a really late night the night before, so I kind of lay down, was moved into this fMRI, and then they asked me a bunch of questions and I ended up falling asleep. It was really relaxing. What can you deduce from stuff like that? Such a great question from Xenon994. Let's have a look. Now, I wanted to focus on a specific issue that many people have in the world, and it's called a stroke. Okay. Now, a stroke occurs when a part of the brain loses blood flow, right? Loses blood flow. So a part of the brain might not get enough blood, which means it doesn't get enough energy, because obviously in the blood is oxygen, and that oxygen is needed for respiration, that respiration is needed for energy. So a stroke is what happens when parts of the brain doesn't get enough energy and therefore starts to shut down. And here's an image of someone's brain from an fMRI, right? From an fMRI, it's actually should be like this, right? And we can use this fMRI to get something like this. This is 2 weeks after a stroke, and what they're looking at is, a lot of the time when people have a stroke, sometimes their parts of their body don't work properly. In this case, we're looking at someone whose grip isn't working properly, because your brain needs to tell your muscles to grip, right? Our muscles to grip is around here, right, around our forearm, and our muscles need to be told to do this from our brain. When you have a stroke, sometimes that part of the brain isn't working properly. And such a great question by Leonardo Pez. What are the orange bits? The orange bits are the parts of the brain which light up, and the fMRI tells us this when the person tries to grip. The person who's had a stroke, this is 2 weeks after their stroke, they try to grip, but unfortunately it's not really working properly. Okay, so this is the result from the fMRI. We can see that these are the parts of the brain lighting up when someone tries to grip. We can see that all this brain is trying to do is work together to get this grip. Now we know this isn't right, and we want that person to move back to the position where they're able to grip properly. So we use this, which is really cool. This transcranial magnetic system is there to go on the parts of the brain. So you can see that this is the front of the person's brain, this is the back of it. And they've put this part, this TMS, into the part of the brain here to stimulate it. Because what they're doing is they're stimulating the parts of the brain that have been damaged. And in doing so, we see these results, right? Over time, the stimulation helps build up different parts of the brain, different connections in the brain, and we can see a reduction in these orange bits over time. I would like you to hypothesize what's going on. So in here at the beginning, we have this kind of messy, the brain is messy neurological connections, the brain is trying to do a grip, but it's not really working properly. They then stimulate the parts of the brain that we now know are in damage. You know, these parts shouldn't be so highlighted, so we then stimulate those parts of the brain, and over time, when that person tries to grip, these are the parts of the brain lighting up. Now, it seems that there's a reduction in the parts of the brain that are lighting up, that are being picked up by the FMRI. At the beginning, there's quite a lot of the brain is being used for that grip, but over time, not much of the brain is being used for that grip. Let's see what you guys think about this. Yes, Leonardo Pérez, that's really cool. They started to heal. They got better at gripping. That's absolutely true. But why? How? What's happening in the brain to make them better at gripping? You're absolutely correct. They are getting better at gripping. They're getting more in control of their grip. Much more. So it means it's easier for them to grip. Lovely idea. We've got this idea that over time they're healing. It's getting easier. Do people sign up to mess up their brain for studies? Lovely idea. The TMS does not at all mess up the brain. The TMS will disrupt parts of the brain, and then once they come out of it, they'll be totally fine. They don't have to work as hard. Vendible sugar, well done. Don't have to. So it's easier to work. Lovely idea. They're not using as much brain power. Yeah, good. A lovely idea. Reduced brain power. Lovely. They are relearning. Lovely idea. That's really cool. They're relearning. It's like, is it like permanently changing the state of their brain? Now, what this TMS does is it stimulates part of the brain. So what that means is that if there's a part of the brain that's not working properly, which a stroke can do, it can stimulate that part of the brain and make it so that the neurons are now more able to work. And as you've all kind of alluded to, what you've all kind of got an idea of, is that what the TMS is doing, what it's doing is stimulating the brain so that neurons work more efficiently. All right? So before when the stroke happened, the neurons were broken, they were separated, and they kind of went back to a place that all of our brains were at when we were newborn. I don't know if anyone has ever interacted with a newborn baby, but this is kind of what they look like. They don't really have control over their body. They're blinking all over the place, their bodies are kind of moving, their hands are just kind of randomly moving around, their legs are kind of randomly moving around. They're not fully in control. That's because their brain is a mess. It's not made good connections yet. Over time, you are able to do this, right? Watch this. Are you ready for something that requires so many neurological connections in the brain? I'm going to do it up here. It's going to be in this section here. This is going to be incredibly difficult, but here we go. I'm going to do this. Are you ready? All right, I'm going to do that. There we go. The letter A. Now, for me to be able to use my hand and my body and my brain to write the letter A requires a huge amount of neurological connection. My brain, over time, needed to learn by being a kid and getting a pen and picking it up and learning to do this. That took ages. I don't know about you guys, but it took me quite a while to be able to write the alphabet. That's because my brain needed to make neurological connections to be able to do that. When someone has a stroke, those neurological connections are kind of broken. And with TMS, with transcranial magnetic stimulation, you can make the brain kind of remake those connections and get to this point of specific, more efficient learning. I think that's really, really cool. So that's why some people are born with synesthesia. Well, synesthesia is a really interesting idea. It's when there are connections in the brain of parts of it that aren't usually connected. So for example, if the occipital lobe, the part where usually we're able to see, is connected to the temporal lobe, which is partly to do with hearing and speech, some people can, when they see something, they might hear a little something. When they hear something, they might see a nice colour. Really interesting. Now, I wanted to finish with this last thing. Thank you, Leonardo, for reminding me that we've got 1 minute left. And what we spoke about earlier, this is really, really cool. This is really cool. Firstly, over to you. What do you think you're looking at? What do you think you're looking at? And why? What's going on here? What is going on in this image? This is one of my favourite images. Surgery on the brain. Exactly, this is definitely brain surgery. Excellent. These are 2 doctors doing surgery on this man's brain. But the man's got a guitar. Why would he have a guitar? What's that got to do? Not sure. He's trying to preserve his guitar playing. Lovely idea. Any other ideas? I'll give you a clue. This man is fully awake. This is when they do minor surgery and they need to make sure the person still knows how to function. OMH, NPH, incredible work. Yes, this man is completely awake, completely alive and healthy, but they've opened up his skull and they are doing surgery on a part of his brain. During this surgery, he is playing the guitar because they can know if they make a mistake in part of the surgery, the guitar playing is going to change, because the part of the brain that they are doing surgery on, we know, has links to memory and muscle memory and auditory submission so that he can play the guitar. I think this is absolutely amazing. If they were to make a mistake, then they would know that immediately and they could fix it as quickly as they can in order to stop this man from having any long-term damaging. I think this is flipping amazing. Now, the biggest question that has already been asked is, does he feel anything? And I agree. This looks almost scary, right? He has been given 0 anesthetic because your brain, well, he has been given anesthetic of the bit of the skull they've opened, but your brain has no sense receptors on it. So if you were to open someone's skull up and poke their brain, the person wouldn't feel that poking because the brain doesn't. So no, he doesn't feel anything other than the fact that his head is open. That's really cool. Really, really cool. Anyway, that's it from me. The idea is that we can learn so much about a brain when it's damaged, like when what Phineas Gage happened to him. He had such issue with the front of his brain. We learned that the front of a brain was to do with personality. We now know that there's this idea of a transcranial magnetic stimulator, which is there to stimulate parts of the brain, and if we stimulate a part of the brain and that part of the body gets better, we can make those connections. The FMRI, which is really cool, we can use that to study parts of the brain and see if there are any damages, like for example this person here who has an FMRI of their grip strength, which is different to a healthier person. I just think it's amazing, psychology. Anyway, in 2 weeks' time, I'm going to be here looking at the psychology of addiction, of different types of addiction, ranging from the more obvious of drug addiction to the less obvious of, for example, gaming addiction and eating addiction. I'm really looking forward to seeing you all in 2 weeks' time. It's been a pleasure. Have a brilliant day and a brilliant rest of your summer holidays. Have a great time. See you later on. All right, bye-bye.